Here we are, lesson 14, conditionals. Okay. Boolean expression, an expression that can only evaluate to true or false. Read the code below. Take a guess what they mean and what will be printed in the console by this program. So here's the console, right? We've got sprite 1 being created at 100x, 200y. So they'll be like, here, wait. 100, 200. So right here. And the other one is 300 and 200. So right here. So those are the blocks being created. And then we have this console log. So this is the stuff that's going to show up down here. So we have sprite 1 y, which is the up and down, is equal to sprite 2 y, which is the up and down. And when we look here, we've got, these are both the same number, the y. So that is correct, right? Because it's equal. So that is true. So when we run it, it should say true down here because this is true. And now we have our sprite 1x, which is 100, is greater than sprite 2x, right? Because there's a greater sign, which is 300. And 100 is not greater than 300, so we know that's a lie. So that's false. Then we do our third one, sprite 1x, 100, is less than sprite 2y, and then sprite 2y is 200, so that would be true. So let's run it. And there's our blocks. And there it is, true, false, true. So that one's true, that one's false, and that one's true. And that's all it is. It's way more, sounds way more complicated than it actually is. Okay, make sure and watch this video. Oh, they're going to give us the answer, which is fine. Okay. So, these are the questions, and these are the code that are creating the question. So we just have to match them up. It gives you the answer here, but let's just go over it. Okay, is the dog sprite's rotation less than the cat sprite's rotation? So rotation is the key. So let's go on to find rotation, and there it is. Is the dog sprite's x less than the cat sprite's x? So less than. There it is, less than symbol. Is the dog sprite's scale? So scale is the key on this one. Is the dog sprite's x greater than? So greater than would be this one, right? Is the dog sprite equal? Equal, right? So there's the equal. And that's it. So this one's not super hard. They just want you to pick out the important parts and recognize which one is actually which. Jeez. Louise. All right. The program draws a race car and a finish line. We're going to figure out when the race car crosses the finish line. The sprites have been set up for you. Do this. Add a console log statement inside the draw loop. that asks, is the X position of the race car less than the X position of the finish line? Right, so all we're doing is the exact same thing that we did the last bubble. X less than X. So X of race car less than symbol X finish line. So we're going to get that information in our console log. And then we're going to add some math in there. Maybe. And it was less than? Yeah, less than. So here's our less than symbol. Let's just run this first. Oh, I forgot to put in the stuff. All right, let's run it real quick. So what's happening here is we're gonna find out when it touches this that it's no longer less than. So let's go ahead and do that again. Console log less than. And now we're going to say X position of the race car. X position of the race car. Race car. And make sure and get that capital right, otherwise it's not going to work, right? Because it has to be the exact same match. Okay. X position of race car is less than X position of finish line. I'm just going to copy this because it'll be easier than typing it out. Okay. So our console log in our function is saying the race car X position is less than the finish line X position. So this is going to keep redrawing, and it's going to say false or true until it actually happens. So check it out. Here's our console log. Run it. False, 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 and then when it hits the finish line, it should change to true. Hey, there it goes. Right? So, again, when it hits the finish line, it becomes true. So all these are false until it becomes true. So the first time it drew the race car, and then it went -2 and redrew it again here, and here, and here, and here, it was all false until it hit the finish line, and then it became true. So that's it. All right, let's see what's going on with the next one. If statement. Okay, Boolean expressions allow us to ask questions. But in order to use these questions to change the program's behavior, we need an if statement. Read the code for the race car program. What will the program do when the car reaches the finish line? Why is the if block inside the draw loop? Okay. So, here's our function. It's going to redraw the background constantly with white. The race car is still going to be moving this way, -2 each time, right? It gets redrawn, so it's going to look like it's moving. Now, if the X position of the race car is less than 100, and 100 is here, right? 50, 100. So here's the line. If it's less than 100, the console log is going to say winner. Right? That's all that says. So let's check it out. Remember, this is the 100 line. And there it is, winner. Hurrah! Hooray! Alright, make sure and watch this video. It's very exciting. Change the fruit. Now that we know how to use if statements, you can do more than just check if the apple has reached the scale of 2. You can turn it into a pear once that happens. Use a conditional in the draw loop to check whether fruit scale is greater than 2. If it is, change the fruit's animation to pear. Alright, let's do it. Alright, so let's run it. And we see the apple's getting larger. It's getting huge. Okay. Okay, so what's happening here? We have our fruit created at 200, 200. The fruit is an apple. The fruit scale is 0.1. And then we have our loop here. Function draw. Background white is getting redrawn over and over and over again. And then here's our math. The fruit scale equals fruit scale plus 0.01. So each time this gets redrawn, the apple is going to get 0.01 larger. And we see that right here, right? It's getting larger. So now we want to throw in that conditional. So here's our conditional. All right, so now what we're going to say is if, what was it? The fruit scale is greater than 2, so greater than 2, greater than, oh wait, fruit scale. We need fruit scale first. Scale. No, we need the math in there first. Duh. Greater than. If the fruit scale, so fruit, if the fruit scale is greater than 2, then we want to change this animation, right? So the fruit set animation is going to change from apple to pear. Fruit set animation to pear. So again, what I did here, I put in this if conditional, meaning once this fruit scale is greater than 2, it's going to change from an apple right here to a pear. I hope. Let's check it out. Come on. It did it. Okay, so again, let's do this again just to make sure everyone's got it. I'm dropping this in. If it's greater than 2, and I'm talking about the fruit scale, right? Because it says it right here. This is it. If the fruit scale is greater than 2, then we want the animation to change. So set animation. And again, we got to make it match up fruit to pear. Reset. Run it. And we're in business. Okay, the simplest Boolean expressions are questions that the computer can answer with true or false. Another way to say that is that Boolean expressions evaluate to true or false. Do this. Can you modify the values of the sprite properties so that each of the Boolean expression evaluates to true? Read through the entire program to see how sprite 1 and sprite 2 are being created with properties. For each Boolean expression, identify the sprite's properties being compared. Change the code in the first 11 lines only so that each of the console log statements is true. Alright. So here are the console logs. So we're saying sprite 2 x is equal to sprite 2 y. Okay, so here's sprite 2. And they want the x and the y to be equal, right? Because this is the equal symbol. So let's go ahead and make this 200. So it's 200 and 200, so the x and the y are both equal. Now, comparison to sprite 2's rotation is less than 40. Sprite 2's rotation is, right now it's at 60, right? Sprite 2 rotation is at 60. So let's just make it 30. So now 30 is less than 40. Okay, sprite 1 scale is equal to sprite 2 scale. So sprite 1 scale 1.5, sprite 2 scale 0.5. So let's go ahead and just change this one to 0.5 so they match up, right? So sprite 1 scale is 0.5, sprite 2 scale is 0.5. So that's true. Sprite 1x is greater than 150. So sprite 1 x, it's at 100, so it's clearly smaller than 150, so we just have to bump it up. Let's make it 160. So now sprite 1's x is larger than 150. And now let's go sprite 2's y is less than 200. Sprite 2's y is less than 200. Okay, when we do this one, it's going to mess up this one up here, right? Because right now the sprites x and y are supposed to be equal, which they are, but right now it needs to be less than 200. So I'm going to change this to 199 and this to 199. So it's still less than 200, but sprite x and y, sprite 2's x and y are both equal still. Now let's run it and hopefully everything is true. And I'm not a liar. Let's go. It did it. Not bad. Alright, onward. Dropped soup. Okay, so when the rotation goes to upside down, the soup disappears. Alright, run the program to see how it works. Alright, I see how it works. I've got two pieces of animation in here, right? I've got the stew and then the bowl. So we want it to change from the bowl with the stew in it to just the bowl with nothing in it when it gets to the certain rotation. Okay, so this should be pretty easy. We're going to put our if-then statement. Okay, if, and then we're going to go less than, with our math, or greater than, greater than, greater than, greater than. All right, and then if the soup rotation, soup. Okay, if the soup rotation is greater than, I don't remember how the numbers work, so let's just do 90 for right now. And then we'll fix it if it's not perfect. Okay, if the soup rotation is greater than 90, then the animation is going to change from the stew to just the bowl. Soup to bowl. Right? So if the soup rotation is greater than 90, then the animation is going to change to the bowl. So let's run it and see if it works. Okay. So what's happening is disappearing at right here instead of upside down. So we'll change that from 90 to 180. And there it goes. Cool. All right, so 90 would be a quarter of the way, and then 180 would be all the way upside down. And that's it. Alien celebration. Okay, make the alien dance when the spaceship reaches the top of the screen. Run the program. Okay, so we want, when this happens, when the ship gets to this point, we want this to move. All right, so let's go ahead and drop in our ifs. All right, so if the spaceship hits 0, and that's up and down on the Y. So let's get our math. If it gets less than 0, right, meaning it goes past that 0, on the Y. Okay, so if the spaceship hits less than 0, meaning beyond this line, spaceship hits less than 0, then we change the set animation of the alien so alien goes to animation alien dancing, or alien dance. And here we go. Okay, that didn't work because the guy's dancing immediately. I'm not exactly sure why that didn't work. All right, let's try. Oh, Duh. Okay, this is a knucklehead mistake. So what I did is I'm saying when the spaceship is greater than 0, it's automatically greater than 0, right? Because this is right here is 0. So he's automatically greater than 0 when the guy starts off. So I need to change that from greater than to less than, which is an easy fix. If you do it right. Okay. So now, here we go. If the spaceship goes to less than 0, the alien dance starts. Let's try it again. He's good, he's good, he's good. Hey! Alright. It works that time. Nice. Magic dinosaur. Make the dinosaur turn into a pterodactyl when it reaches the sky. Run the code and see how it works. Okay, so the dinosaur is doing its thing. And we want it to just change. So this is the same as the last one, really. Get our conditional in there. If, and it's on the Y, right? If let's see here. Let's have it when it hits right here. No, let's have it when it hits right here. Okay, Y150. If we gotta get our math first. Less than, remember, because we had it wrong last time, so we want the less than in there. If the dinosaur Y dino. Okay, if the dinosaur Y goes to less than, we're doing what? 150? If the dinosaur Y goes to less than 150, then we go to set animation. The dinosaur changes from the Tyrannosaurus, which we have it here, to pterodactyl. Alright, let's see if it happens. Yay, it did it. Cool. New block, visible. Okay, this one they want the balloon to keep growing and then disappear and then the pop to show up. So let's go to control, drop in our cool if-then statement. So if, we'll get our math greater than, right, because it's getting bigger. Okay, if balloon scale, because that's what we're messing with right now is the scale. And I have to spell balloon right, or it won't work. Still can't spell balloon right, that's pretty sad. Okay, if balloon scale is less than, I don't know, it doesn't really matter. Let's say 0.5. And it's giving me the naughty triangle because I didn't put a 0 before the 0.5. Okay, if the balloon scale is greater than 0.5, what do we want to do? We want the balloon to become not visible visible. We got to put in some math. Okay, we want the balloon visibility to be false, right? Because we want it to be gone. We don't want it to be seen. So balloon visible, false. So it's not going to be seen. But we want the pop to be seen. So we have to create the pop in here. So let's do that. Variable. Or actually just create sprite. Okay, so we're going to create our pop at 200, 200. And we're going to set the animation of the pop to be the pop. But we don't want it to be visible right now. We want it to be hidden. Right? So let's find our visibility. So the pop visibility is going to be false, right? Because it's not showing up. Actually, you know, let me get rid of this right now. So here's what we have right so far. We have our balloon being created at 200, 200, and the animation is set to the balloon. It's scaled at 0.1, so it starts off pretty small. And then we have our pop created at 200, 200. The animation is set to the pop, and the pop visibility is false, right? Meaning it's not showing. Then we have our function. These bells, man. Then we have our function. The background's being redrawn over and over again, white. The balloon scale is going up 0.001 every time it redraws it, so it looks like it's getting bigger. And then we have our conditional. So the balloon scale, when it reaches larger than 0.5, the balloon visibility is going to go false, so you're not going to be able to see it. And hopefully this thing's going to get bigger and then just disappear. Let's see. Come on. All right, it went invisible. So that's a good thing. So now we need to add the visibility of the pop in our conditional. So we're saying if the scale gets above 0.5, the balloon goes false and you don't see it, but the pop becomes, you can see it, becomes true. So here's our math. And then we'll get our visibility sprite. Okay. And then this one's going to be the pop, right? Because we have to make sure it matches the pop visibility, pop, pop. So pop visibility equals true. So it's the program starts off with the pop being false or hidden, not true. So visibility, false, not true, not happening. And then in the function, when it gets to 0.5, larger than 0.5, the visibility becomes true. And the balloon disappears, becomes false. All right, let's see. Cross our fingers, dot our I's, let's get it. Go, go, go. This is tense. Very tense. All right, it did it. You know what, let's make this 0.25, it'll be faster. There we go. Okay, it worked.